Okay, hello everybody. Cozy Azeroth, aka Zachary Fruling here. And I recently did a 10-part series going through the Learning Basic, aka Teach Yourself Basic programs for the Texas Instruments TI-99 for a home computer, my favorite retro computer, the computer I had when I was a little kid. And one of the things that came along with the computer originally was this beginner's basic book. And I thought it would be fun to just go through this book chapter by chapter and do all of the sample programs and all the sample activities inside an emulator for posterity and for anyone's edification, for a little trip down memory lane, for anyone who likes the TI-99 4A, to learn about the basic programming language, for anyone who's interested in some retro programming, so on and so forth. So what we're going to do, I'm going to read through the introduction, and then we're going to dive into chapter 1, which is called the immediate mode, as opposed to program mode. And the immediate mode is where the computer just responds to a command immediately. You type print something, it'll print that thing on the screen. You do a calculation, it'll print the answer on the screen, so on and so forth. So pretty basic. And there are only a few chapters in this book, 6 or 7 chapters, I think. And so I'm going to make this a several-part series where we run through this entire book and do all the activities and write all the sample programs, type them into the emulator, and see what the TI-99 4A can and could do. Without further ado, let's dive in. So the introduction, you and computer programming. So we're just going to read the introduction here. So, bear with me while I run through this preliminary material. This book is your guide to an adventure, learning to program your Texas Instruments computer. Even if you have never worked with a computer before, you can use this book to teach yourself, your family, and your friends how to use and enjoy your computer. Computers are rapidly becoming an everyday part of our lives. We're very familiar with bank statements compiled and printed by computers. We watch computerized scoreboards at sports events. We even see computer-aided instruction in our children's classrooms. Almost everything we eat, wear, and use has been handled at some point in the manufacturing process by computer-controlled machinery. By learning to program and interact with your computer, you'll be joining this technological revolution of the computer age. You'll understand more about how computers work, what they can and can't do, and why they are becoming so widely used. Best of all, you'll be able to apply the power of your computer to the areas that appeal to you, your business and finance, your hobbies, your family's needs and interests. Perhaps we'd better warn you, many people become fascinated with computer programming as an exciting and entertaining hobby, so don't be surprised when you and all the family find yourselves wanting to learn about and use your computer more and more as time goes on. What is computer programming? Nothing mysterious. Programming is simply communicating with a computer, telling it what to do and when to do it. To program your computer, you only need to learn 2 things: the language your computer understands and the way you talk to it. No lengthy training periods or super sophisticated skills are required. Okay, TI Basic. In order to communicate with any computer, you'll need to learn its language. The language we'll be exploring here is a form of BASIC, short for Beginner's All-Purpose Symbolic Instruction Code. BASIC was developed by John Kameny and Thomas Kurtz at Dartmouth College during the middle 1960s. Although BASIC is only one of many computer languages, it is one of the most popular in use today. It's easy to learn and simple to use, yet it's powerful enough to do almost anything you'd want to do with computers. Some basic features may vary slightly from one type of computer to another. The similarities, however, far outweigh the differences. In fact, you can think of these different forms of BASIC as dialects of the same language. The dialect used by the TI computer is called TI Basic. As you read this book and try out the examples on your own computer, you'll notice one striking fact about BASIC. It's very much like English. You'll see words like print, go to, run, and end. The meanings of these words in BASIC are almost identical to the definitions you already know and understand. This fact is what makes BASIC so easy to learn and fun to use. Now, how do you talk to the computer? Well, take a look at the keyboard. You see there are the letters of the alphabet, numbers, punctuation marks, and other special symbols, many of which you've seen before on typewriter keyboards. Everything you'll need to use to communicate with your computer is right there on the keyboard. You, quote, type your instructions and the computer, quote, hears them. It's essentially as easy as that. About this book. This book will guide you step by step through the process of learning TI Basic. While the book is not a complete textbook on basic programming, The material included here will give you a good foundation for the continued development of your programming skills. Once you are familiar and comfortable with BASIC, you'll be ready for the more advanced material found in the user's reference guide. Throughout the book, each explanation of a statement or command is followed by one or more examples for you to try out. Also, you can, and should, experiment with other examples of your own to help you become thoroughly acquainted with the capabilities of your computer. You'll find some special sections marked Experiment throughout the book. These are for you to try out on your own. In the first chapter, we'll explore some of the basic statements that can be performed in what's called the immediate mode, that is, directly from the keyboard. Do you want to add 3 and 5, or create sounds, or make designs, or computer graphics on the screen? You can do all of these in the immediate mode, and you'll find out how to do them in Chapter 1. Chapters 2 and 3 take you on into programming. You'll learn how to, quote, structure a program, issue commands your computer can follow, perform mathematics, use graphics and sound more effectively, and create loops, program segments that repeat themselves. Then, in Chapters 4 and 5, you'll get further into some of the exciting things a computer can do. Did you know that your computer can play games, make music, draw colorful designs on the television screen? It can, and you can teach it how. At the end of the book are several appendices of reference information you can use as you develop your own programs. Of special interest to those who want and need to use the computer as a powerful computational device, Appendix D outlines the mathematical operations and functions of the computer. You'll also find a convenient alphabetized index of topics to help you look up features you want to review. Now that you know what's ahead, let's waste no more words. Let's get started in the immediate mode. Chapter 1. The immediate mode. In its immediate mode, your computer immediately performs each basic statement you've typed in as soon as you press enter. Because you can see an instant response on the screen, the immediate mode is a good way to introduce and explore certain basic language statements. Before you begin learning BASIC, take a few minutes to review the operation of the keyboard. You'll find a complete key tour in the user's reference guide. When you are ready, turn on your computer. The display screen should look like this, which we're going to take a minute to look at. Need to restart the system though. Let's restart this. Oh, you can see the start screen. There's the start screen, very familiar to anyone who's at a TI-99 4A. Let's go back to the guide. Press any key on the keyboard. The display will then show the master selection list. If a module is plugged into its slot on the console, the title will appear as the second item on this list. So any key on the keyboard. And sure enough, we get a screen that says, press 1 for TI Basic. Note, when you're ready to leave TI Basic, just type the word bye and press the Enter key. The computer will then return to the main title screen. The examples shown in this book are printed in uppercase, large capital letters. If you want to reproduce the examples exactly as you see them here, press down the alpha lock key. However, in most cases, the computer accepts either uppercase or lowercase characters. Also, see important keyboard information on the inside front cover of this book for details about the function keys: clear, left arrow key, right arrow key, etc. Okay, press the 1 key to select TI Basic. I'm actually going to move the camera a little bit because I think that it's going to be in the way of some of the action on the screen here. So let me take this webcam group and we're going to move it to the, let's just move it to the top right here, get it out of the way. I think that'll work. There we go. Okay, press the 1 key to select TI Basic. The display now shows that the computer is ready for you to begin. The cursor and prompting character. Cursor, of course, being a new term for a lot of folks back in the day. So we're going to press 1 for TI Basic. And we do see TI Basic ready, as shown in the guide. The flashing rectangle is called the cursor. It tells you that the computer is ready for you to use. Whenever you see the cursor, you know that it's your turn to do something. The prompting symbol marks the beginning of each line you type. The print statement. The print statement means exactly what it says. You merely type the word print, followed by a message enclosed in quotation marks, and the computer prints the message when you press enter. So here's an example. Print, quote, this is a message, end quote. So the word print, a space, beginning quotes, your message, whatever it is, and end quotes. Remember to press the Enter key after the ending quotation marks. This is the computer's cue to perform what you have requested. All right, well, let's give it a try. Let's type print, this is a message. Okay, so print, this is a message. End quotes. Don't forget the space, don't forget the quotes, especially the end quote. And the computer prints, this is a message. And of course, print is a callback to old paper readouts, ticker tape type readouts, and or punch cards back in the day. So printing to an output, in this case the output is the screen. Okay, remember to press the Enter key after the ending quotation marks. This is the computer's cue to perform what you have requested. And we see something very similar to this. We have the prompter and the flashing cursor. You typed this, then pressed Enter. The computer follows your directions and prints this. And that's exactly what we see on the screen. Okay. Let's try another print statement. Type this. Print, hi there, with an exclamation point and quotation marks. Let's try it. Let's see, do they want a comma in there? No comma. Print, hi there. Print, hi there. And there we go. Hi there. Proof of concept. Note, if you accidentally press a wrong letter or symbol key, just use the left arrow key to move the cursor back to the incorrect symbol, then retype. Now press Enter and the computer will do just what you told it to do. And I'm going to try it again. I think because I'm using an emulator, I'm going to have to make this change using the regular backspace key, but bear with me. Print. So let's say we made an error. Hi, there's. There we go. Oops, there's an error. Let's back up. And like so. And we get hi there. Oop, I forgot the exclamation point. No big deal. Okay, these are left on your screen from previous examples. You can see we have some previous examples still on the screen. You typed this, the computer printed this. Did you notice the way the lines moved up on the screen when you pressed Enter and again when the computer finished printing its line? This procedure is called scrolling. The cursor tells you it's your turn now and shows you where the next line will begin. Let's try another example. Type these words, but don't press Enter just yet. Okay? Let's do it. Print, I speak basic, do you? Okay, but we're not going to hit Enter yet. Print, I speak basic, do you? We're not going to hit Enter yet because it told us not to. So we have print, we have one space, we have our statements, I speak basic, do you, and in quotation marks. When you run out of room on a line, just keep typing. The computer will automatically scroll to the next line, and that's what happened. It automatically scrolled to the next line. Okay, now look at the screen and check what you've typed. If there are any errors, just use the left arrow key until the cursor has reached the error. Then retype the line correctly from that point on. This is only one correction procedure. You'll learn others as you go along in the book. When everything is correct, press the Enter key. You'll then see, you typed this, print I speak basic do you, scrolled on to the next line, and when we hit Enter, it will print I speak basic do you. There we go. I speak basic do you. If you want to try some other print statements on your own, go right ahead. Each time you press Enter, you'll see the lines on the screen scroll upwards. The top lines will finally begin to disappear as the screen's capacity, 24 lines, is reached. Okay, let's do one more print statement. Print, oops, need a space in there, follow Cozy Azeroth on Twitch and subscribe on YouTube. There we go. Follow Cozy Azeroth on Twitch and subscribe on YouTube. Very 21st century statement. Boom, boom. Don't forget to like and subscribe. The call clear statement. You've probably noticed that your video display has begun to look rather cluttered. If you want to clear the screen for a less distracting appearance, you can use the words call clear. Okay, clutter, 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 clutter. We have lots of clutter on the screen here, so let's clear the screen. The cursor moves, the prompter stays at the start of the line. Type call clear, then press Enter. Call clear wipes the slate clean for your next request, and your display will look like this. It will look pristine. Only the prompter and cursor show. So we're going to clear the screen. Call, clear. And of course, call statements are sort of unique to TI Basic. Other languages have different ways of clearing the screen, but TI Basic had this functionality called call, which calls various subroutines. Call clear to clear the screen, call sound to do sound, call key to look for key presses. Basically, calling a subroutine is the idea, but call clear will clear the screen, and all we have is the prompt and the blinking cursor. Note, as you work through this book, you'll see several basic statements that begin with the word call. Your computer has been, quote, taught to do certain things by having some special purpose programs built into it, and a call statement tells the computer to call the built-in program named in the statement. Error messages. Every computer programmer makes mistakes, so don't hesitate to try experiments of your own as you go through the examples in this book. Errors will not hurt the computer. It quickly recognizes things it can't do and gives you an error message and a tone to tell you to try again. When mistakes happen, just identify the error and retype the instruction correctly. Some of the most common errors are typing a wrong letter and omitting a necessary part of the statement. For example, here are a few mistakes your computer doesn't like in a print statement. A misspelling in the word print, a missing or extra quotation mark, or extra spaces in the word print. Let's experiment with some intentional errors to become more comfortable with error messages. Misspelling the word print. Okay, so we're going to purposely misspell print. Type P-I-R-N-T. This is a message. We should get a error message that says incorrect statements. So P-I-R-N-T. P-I-R-N-T. What were we supposed to type? This is a message. This is a message. And we should get an error message. Incorrect statement. Looks very much like the sample screen in the book. Okay, let's try missing or extra quotation marks. Print quote. This is a message with no end quotation mark. Okay, print. This is a message. No end quotation mark. Again, incorrect statement. Interesting that there's a space after this incorrect statement, and there's no space here. I'm not sure exactly why. And extra spaces in the word print. Okay, so P space R-I-N-T space quote, this is a message. Again, incorrect statement. Experiment. Try a few more messages with the print statement, introducing intentional errors so that you will become familiar with the error messages. We'll discuss other error messages at appropriate places throughout the book. One question I have, because it's been a long time since I've done this, do we need the space between print and the first quotation mark? So print, this is a message. And you'll see right here that there is no space between print and the quotes. And that works okay. You don't actually need that space, interestingly enough. The parser knows what you mean. I don't know what other intentional error could we make. How about an extra quotation mark? Print, quote, quote, this is a message. Yep, it doesn't like that. What if we put two pairs of quotes? Does it like that? Quote, quote, this, keep making a typo there, this is a message. Quote, quote. Nope, doesn't like that either. Okay, get the idea, I believe. Error correction. There are several ways to correct typographical errors before you have pressed enter. You can press erase to erase what you've typed on a line. If you spot the mistake just after you've made it, use the left arrow key to move the cursor back to the error, retype the line from that point on, and then press enter. Note that the character is not erased as you backspace over them, unlike the modern use of backspace. So I guess they really do intend it to correspond to like the left arrow key. You know, our modern backspace key deletes as it goes. Okay, let's see, continuing. Only the prompter and cursor show. Let's clear the screen. Oh, actually, what happened here? I think we ended up with the same page twice. We sure did. Yeah, whoever scanned this have two page 11s in there, so oops, sorry about that. Let's move on here. Okay. We're on the right page now. Yep, 13. If you finish typing a line and you make a mistake near the beginning of the line, use the left arrow key as above, retype the letter or word, use the right arrow key to move the cursor back to the end of the line, and then press enter. Note that the right arrow key does not erase as it moves the cursor. If you need to erase a character or word, use the spacebar to advance the cursor over the character. Or you can just disregard the error and press enter anyway. The computer may give you an error message, but it's very forgiving. Simply retype your line, correctly this time, and press enter again. Okay, moving on. The let statement. The let statement is used to assign a value to a variable. Variables are, quote, names given to numbers or to phrases containing both numbers and letters, and certain other characters. Although there are two types of variables, in this section we'll consider only those variables that give names to numbers. These are called numeric variables. A numeric variable is just a name given to a numeric value. In the let statement, the word let is followed by the variable, the name, then an equal sign, and finally the numeric value you're assigning to the variable. Variables can be up to 15 characters long, but they are generally kept fairly short for convenience. Let's try a few examples. Type in the following lines, pressing enter at the end of each line. Okay, so let a equals 5, let a2 equals 8, and let alpha equals 10. I'm not sure I can remember all that. My memory's getting worse in my old age. So let a equals 5. Oops, equals 5. Okay. And then let's type let a2 equals 8. Oops, I keep introducing extra spaces there out of habit. Modern programming. Let's back up. Equals 8. Okay. And let alpha equal 10. Okay. So basically we're taking these names A and assigning that to the value of 5. A2 has a value of 8 and alpha has a value of 10. You can think of variables as labeled boxes that hold assigned values. This is one of the best computer graphics ever, I think. Let a equals 5. You have a box called A, and the number 5 goes inside that box. Let a2 equals 8. You've got a box called a2, and it holds the value of 8. Let alpha equal 10. And we have a box called a box called alpha, and it holds the value of 10. Only one value at a time may be assigned to a given variable, but you can change a value easily. Type these successive let statements, pressing enter after each line. So if we type let a equals 5, then 5 goes into the box, so a will equal 5. And then if we retype this let statement with a new value for that variable, that will replace the old value for the variable. And this cute little graphic, 5, flies away and goes into the digital void. So let's do that. Type a equals 5, let a equals 5. Okay, then we're going to immediately type let a equals 8. Okay. The value of a is no longer 5. The 5 has been replaced by the value 8. Now let's use print statements to check the values we've entered. Clear the screen, then type print a and press enter. Okay. Call clear. Clear the screen. Now, even though we've cleared the screen, the computer, of course, is still holding on to those values. So we're going to type print a, and it should give us the value of 8. So you type this line, print a, computer prints the value of a. Print a. And sure enough, we get 8, as predicted. Did you notice that this print statement is different from the print statements we explored earlier? We didn't put quotation marks around the a. That's because we didn't want to print the letter a. We only wanted to see the numeric value assigned to a, in other words, assigned to the variable called a. Now check for the values of a2 and alpha. Remember, press the enter key at the end of each line, even though it isn't shown in the illustration below. So we're going to type print a2 and then print alpha. Print a2, and that's 8 as well. And we're going to type print alpha. And we should get 10, which we did. Looks very much like what we see in the book. A single print statement can also be used to print 2 or more things. Clear the screen and try these examples. Okay, we're going to type print a2, comma alpha. When a comma separates a2 and alpha, Note the distance between 8 and 10. So the comma introduces some space between the two things being printed. So print A2, comma, alpha. Print A2, comma, alpha. And we get 8 and 10, where indicated. Approximately halfway across the screen. I'm not sure if it's exactly halfway. Could be. Now try these. Let's see. Let AL equal 6. Let Albert equal 8. Okay. Let's enter those first. AL and Albert. Let AL equal 6. Let Albert equal 8. Now we want to print AL and a semicolon and Albert. When a semicolon separates Al and Albert, note the distance between 6 and 8, a smaller distance. Okay, print AL semicolon Albert. AL semicolon Albert. And we get 6 and 8 printed a little more closely together. So far, so good. We'll be programming in TI Basic before you know it. The computer divides the display screen into two horizontal zones. When you use a comma between the two or more variables in a print statement, you are telling the computer to print the values in different zones. On the other hand, the semicolon instructs the computer to print the numbers close together. If you want to print the variable's name along with its value, you can. Remember our old friends, the quotation marks? Here's where we'll use them again. So we're going to type let Bill equal 25, then we're going to print quote Bill equals, then end quote. We're going to use a semicolon to keep the items close together, and we're going to have the variable Bill, and of course Bill equals 25. So let's type these in, let Bill equal 25. Keep doing that, making that mistake. Habit. Let Bill equals 25. And then we're going to type print Bill equals, do you have a space in there? No space. We're going to do it exactly as it's shown, however pedantic this is. Semicolon and then Bill. Okay, and we should, if we've done everything correctly, get Bill equals a little space and then 25. And that's exactly what we get. Exactly as it's shown in the book. Bill equals 25. In other words, we've printed the text Bill equals, and then the variable for Bill, Bill being a variable name, is 25. So it prints the value for Bill. Did you remember to press enter at the end of each line? I did remember to press enter at the end of each line. Now that you've learned to assign values to a variable, what can you do with this new skill? Let's find out. First, use the call clear statement to clear the screen. Okay, let's do that first. Call clear. Okay. After variables have been assigned values by let statements, the print statement may be used to perform arithmetic operations on the variables and to display the results. So here's an example. Let W equal 4, let T equal 8, and we're going to say print W plus T, and then T minus W separated by a semicolon. We should get 12 and 4. So let W equal 4. And we're going to say let T equal 8. Okay, notice nothing happens. We're just assigning the variables. We haven't printed anything to the screen yet. Then we're going to type print W plus T. And semicolon, I think it was T minus W, right? Yep, T minus W. T minus W. And we get 12 and 4, just as shown in the book. You can also perform multiplication and division by using an asterisk to multiply and a slash mark to divide. For example, print W asterisk T, or W times T multiplied by T, and T divided by W. Okay, so print W times T, W asterisk T, that's the best looking asterisk in any programming language, W times T, and T divided by W. Semicolon T divided by W. We get 32 and 2, exactly as shown in the book. Prettier in the actual environment because it's blue, or cyan. Note, in TI Basic, the let statement is not the only way to assign a numeric value to a variable. Your computer will also accept the assignment without the word let. So we can say Jack equals 3, Jill equals 5, print Jack times Jill. Okay, and that should be 15. So Jack equals 3, Jill equals 5, and we're going to print Jack times Jill. Print Jack times Jill. And that will give us 15. 3 times 5 is 15. In other words, the word let is optional in TI Basic. Your computer will accept the assignment either way. Experiment. Try other variable names and numeric values, and experiment with using the comma and semicolon to separate the variables in the print statement. Try adding, subtracting, multiplying, and dividing these variables in print statements. Discover what mistakes will cause error messages. Okay, so let's see what we can do. This is just going to be a fun exercise. We're going to say let Zachary equal, let's see, let's just do the number of letters in my name equals 7. Let Fruling, my last name, equal 8 letters. And now let's just have some fun doing some math. We're going to say print Zachary plus Fruling. That should give us 15. And we're going to say print Zachary minus Fruling. And that gives us -1. Let's do a little multiplication. Print Zachary times Fruling, which would be 56. Now let's see, this is going to be a fraction here. Print Zachary divided by Fruling. That'll be 7/8, right? Which is 0.875. Now we're going to intentionally do an error message here. Print Zachary divided by 0. You can't divide by 0. Warning, number too big. Yeah, it's just not going to be able to calculate that. Okay. I think everyone gets the idea. The call sound statement. Here is another of the call statements. Remember the call clear statement we discussed earlier? We hope you've been using it to occasionally to erase the display screen. In fact, let's do it right now. Call clear. Boom. Using the call sound statement, you can produce sounds over a range of frequencies from 110 to more than 44,000 Hz. 1 Hz, abbreviated Hz, is equal to 1 cycle per second. Thus, the sound you generate with your computer can vary from 110 cycles per second, A below low C on a piano keyboard, to over 44,000, well above human hearing limits. In fact, just as a side note, I'm a ham radio operator, and I first learned about frequency from messing around with the TI-99 4A, and of course when I started studying for my ham radio license, I already knew what Hertz meant for frequency of radio signals, which are of course way higher frequency than this. And radio frequency, not audio frequency. Okay, you can control the duration and the volume of the sound. The time the sound lasts, or the duration, ranges from 1 to 4,250 milliseconds. 1,000 or 1,000 milliseconds equals 1 second. So the duration range could be stated as being from 0.001 to 4.250 seconds. Volume selections are scaled from 0 to 30. 0 and 1 produce the same sound level and are the loudest. 30 produces the quietest tone. This example shows how to use the call sound statement. Okay, let's analyze this. Call sound, we have parentheses, 1,000, 440, and 2, separated by commas. Okay, be sure you have a space between call and sound. No space after the sound. Okay, interestingly enough. The language is a little inconsistent on the use of spaces after words and whatnot. Like print requires a space, doesn't require, but encourages a space before the initial quotation mark. So no spaces there. That 1,000 is the duration in milliseconds. That should be 1 second. Tone frequency is hertz, 440, and we said that is 440 is a C, right? I think, or is it an A? I can't remember. Forgetting my music theory. And my grandma's rolling over in her grave. And loudness, volume. So let's type that in. Call sound 1,000, 440, and 2. Call sound 1,000, 440, and 2, and we should get a sound. And we do. That lasted 1 second. Notice that the three values that control the sound are enclosed in parentheses following the words call sound. This example will produce a note of 440 Hz. It is A above middle C, it was an A, okay. With a duration of 1000 milliseconds, or 1 second, and a volume of 2. Quite loud. Try the example now to hear the tone quality of your computer. Okay, let's try it one more time. No, we just did it, but let's try it again. A above middle C, okay? You can play more than one tone in a single call sound statement. Let's add a second note and see how this enhances the sound. Okay, we can get two sounds together. So let's look at this before we type it in. Call sound 1000, 440, 2, and then 659 as a second tone, an E, and the loudness. Okay, let's do it with the same duration. Okay. Call sound, sorry, I have to flip back and forth a little bit, 1440, 2, 40, 2. Now we have 659, 2. 659, 2. Let's make sure it looks exactly as entered. Call sound, 1442, 659, 2. 1442, 659, 2. We'll get two tones, both of which will last 1,000, and I'll bet you, or 1,000 milliseconds, 1 second. I'll bet you they harmonize to produce a nice little chord. There we go. Note, because the statement above contains exactly 28 characters, letters, spaces, and symbols, the cursor will move down to the next line as soon as you type the closed parentheses symbol. Be sure that you remember to press enter. Notice that the prompting symbol stays at the beginning of your line. You only had to type the duration value, the number code that determines how long the sounds last, one time at the beginning of the call sound instruction enclosed in parentheses. Both of the sounds must last for the same length of time. On the other hand, you can vary the loudness values. What would happen if you typed 5 instead of 2 for the second note's loudness? Try it. Okay, let's do that first. Okay, so call sound 1000, 440, 2, and then 659, 5. So the second tone will be less loud. I can hear the difference. I'm not sure that it's obvious. Let's, what were the max values again? Let's see. Zero to 30. Okay. Let's call sound 1000, 440, 2, and let's do 659, and let's do 28. So the second tone will be quite soft. It's there, but you can barely hear it. Let's find a middle ground. Call sound 1000, 440, 2, 659. Let's do 15, halfway there. Yeah, you can hear it this time, but the second tone is a little softer. Okay, next, try a 3-note chord. Okay, we're going to add a third tone. So call sound 1000, 440, 2, that's the first tone, 659, 2, that's the second tone, and 880, 2. Okay, let's just read through the next line here. Okay, third, first is 440, 2, that's an A. Second is 659, that's an E, and 880, 2. Let's see what we get here. Call sound 1000, 440, 2, 659, 2, and let's see, it was 880, 2. 880 is double in frequency, so it should be another A, right? Just an octave higher. There we go. Hear the octave there with a tone in between? Part of this call sound statement extends to the second line, since TI Basic uses only 28 printing positions per line. This gives large, clear, readable text on the screen. You can produce up to 3 tones and 1 noise simultaneously over a given time duration. Noise is rather hard to define in words. It's best for you to experiment and hear for yourself. Remember, one person's noise may be another person's music. Getting philosophical here. Computer age relativism. To produce noise instead of tones, replace the tone frequency with a negative integer from -1 to -8. Try these examples. Okay. Call sound 1000 minus 2, comma 2. Same duration and loudness as before, and the -2 will give us noise instead of tones. Call sound 1000, -2, and 2 for the loudness. Did I get that right? I did. Let's see what we get. We should get some noise instead of a tone. Okay. You can also use variables rather than actual values in the call sound statement. Oh, actually, let's do this other example first. Call sound. Type this carefully to make sure we don't make any mistakes here. 1000, 440, 2. Okay, and then we're going to have 659, 2. 659, 2. And we're going to have 880, 2. And we're going to have -3, 2. So we're going to get 3 tones and some noise all at the same time. -3, 2. Okay, let's hit enter. Yep, so we had our octave with a note in between and some noise on top of that. Okay, you can also use variables rather than actual values in the call sound statement. For example, let's use these variables. T equals time, or duration, V equals volume or loudness, C equals 262, middle C on the piano, E equals 330, or an E, and G equals 392. Okay, so type in the following let statements. So let T equals 1000. Okay, let V equals 1. Okay, so we have 1000 milliseconds, volume is 1. C equals 262. C equal 262. Okay, let E equal 330. And let G equal 392. 392. Okay. Now you're ready for the call sound statement. Type call sound. We're going to have the time, which is 1000 milliseconds. We are going to have C, and then the volume. We are going to then have E in the volume. The volume is going to be the same for all of these. And we're going to have G and the volume. And so we should get a nice C, E, G chord. C chord. Plain old C chord. Want to do it one more time? Why not? Call sound. So T is 1000 milliseconds. C, V, E, V, G, V. Just to clarify again, so T is the time, 1000 milliseconds. C is the frequency for, oop, I made a typo, didn't I? I sure did. I'm going to go fix this typo. There we go. So we're going to have C, which is 262, played at a volume of 1. E, which is 330, played at a volume of 1. And G, which is 392 hertz, played at a volume of 1. A C chord played for 1 second. Okay. Experiment. Experiment with other values for duration, tone, volume, and noise within the required range of values for each. A list of musical note frequencies is included in Appendix A. You'll soon be able to create imaginative sound effects for use in your future programs. The immediate mode is quite helpful for this type of experimentation. Should we go check out the appendix real quick? It's probably at the end, right? Let's see. Do we get is the appendix included here? Let's see if it's included. I did not scroll ahead to look. we have various appendices here. Let's see. Oh, this graphics. We're trying to find the sound appendices here. Appendix. Okay, here we go. All right. What can we do? Let's see. Middle C. Let's do high C. Let's do a much higher C chord. How about that? And we'll do it for twice as long. Call sound. So 2000. And we're going to do high C, which is 523. These are approximate, of course, because the actual values are fractional. So that's why they're so weird. Okay, 523 hertz. 523. And we're doing it at a volume of 1 was perfectly fine. Let's do a high E, which is 659. 659, comma 1. And then let's get a G in there, 784. 784, comma 1. And let's do an even higher C here, 1047. We'll close it off with an octave above C above high C, so 1047. 1047, comma 1. Oh, it didn't like that. Why didn't it like that? 523, call sound, 2000, 523, comma 1, 659, comma 1, 784, comma 1. Maybe you can only do 3 tones. 3 tones and a noise. Call sound 2000, 523, comma 1, 659, comma 1, and 784, comma 1. Might be able to only do 3 tones and a noise. There we go. It lasted for 2 seconds. So that's it exactly. You can have 4 tones, you can have 3 tones, and 1 noise going at once. Let's go back up to chapter 1. Excuse me. Okay. Graphics. Call VCHAR and call HCHAR. One of the most exciting things you can do with your computer is to create colorful designs right on the screen. With your computer's graphic capability, you can make a design, draw a picture, create a game board, and so on. In this chapter, we'll introduce you to 2 simple yet important graphic statements. Call VCHAR and call HCHAR. Call VCHAR and call HCHAR are used to position a character or draw a line of characters on the screen. Later chapters will show you how to choose and combine colors and how to use graphic statements in programs. Earlier we mentioned that TI Basic uses 28 printing positions on each line. For graphics, however, the computer allows 32 character positions on each line. Think of the screen as a grid of square blocks made up of 32 columns and 24 rows, as shown right here, if I can get it all on the screen. There we go. So 32 columns and 24 rows, columns being vertical and rows being horizontal. Each square in the grid is identified by 2 values called coordinates, a row number and a column number. For example, the coordinates 5, 7 mean the 5th row and the 7th column, and the coordinates 10, 11 mean the 10th row and the 11th column. Okay. Oh, here we go. 5, 7. 5 down, 7 over. It's interesting because now we tend to do X and Y, but this is actually rows and columns, so it's backwards than compared to modern ways of representing this. 10, 11. 10th row, 11th column. The first thing we want to try is to place a character in a particular square on the screen. For the time being, let's consider that a character is any one of the 26 letters of the alphabet, the numbers 0 through 9, and certain other symbols, like the asterisk, the plus and minus signs, and the slash. Later on, in Chapter 5, you'll learn more about how to define other characters for graphics. Each character is assigned an identifying numeric value of its own, and the values for the full character set are given in Appendix B. By using either a call VCHAR or a call HCHAR, naming the 2 coordinates, row and column, and identifying a character by its numeric value, You can place the character in any spot you choose. Here's the form used for these two statements. So we have call VCHAR, parenthesis, 12, comma 7, comma 42. So let's analyze this. We need a space between call VCHAR and VCHAR, parenthesis, row number, column number, so row 12, column 17, and the character code 42 for the asterisk, and a close parenthesis. Try this example and you'll see an asterisk appear near the center of the screen. So let's clear the screen first. Call clear. And let's type this statement in. Call VCHAR, parenthesis, and we said it was 12, 17, and 42. 12, 17, 42, and we should get an asterisk, it said, near the center of the screen. Row 12, column 17. And we do. We get an asterisk right there, close to the middle of the screen. Let's try a few more examples. First, clear the screen by typing call clear and pressing enter. Okay, let's do that. Call clear, clear the screen. Now type call VCHAR 15, 10, 67. Okay, call VCHAR 15, 10, and 67. 15, 10, 67. So that should be row 15, column 10, and then 67. And I'm not sure off the top of my head what character 67 is, so we'll find out. The letter C. Don't forget the parentheses in the statement. They're important. Okay, so as predicted, we typed in the call VCHAR statement, row 15, column 10, character code 67, which is the letter C, and we did get a letter C right there near the middle of the screen. Now try the call HCHAR statement. Okay, so we just typed that, so we're going to leave it on the screen. Call HCHAR, and we're going to say 16, 10, 67. 16, 10, 67. Press enter, and we're going to get a C right below that. Right there. So let's see. The call VCHAR statement you used earlier, you just type this. When you press enter, a C appeared in row 16, column 10. That's what happened. The order for entering the row number, the column number, and the character's numeric value is the same for both call VCHAR and call HCHAR. And they both do the same thing when you are positioning a single character on the screen. If you want to draw a line of characters, however, you'll find that there is a distinct difference between the functions of the two statements. Call VCHAR causes a vertical column of characters to appear, while call HCHAR draws a horizontal row of characters. To draw a line with either statement, we must add a fourth numeric value to the statement, the number of repetitions we want. This number controls the, quote, length of the line. Clear the screen, type call clear and press enter, and let's try a vertical line. Okay, let's clear the screen, call clear. We're going to try a vertical line. So call VCHAR, oops, CHAR, and let's see, we're going to have 11, 10, comma, 86, 8. Okay, so let's analyze this. Before we hit enter, let's see what we should get. So we have the row number, row 11, 10th column, numeric value for V is 86, and then 8 repetitions. So we should get 8 instances of the letter V on the screen. And we do. 1, 2, 3, 4, 5, 6, 7, 8. In a vertical arrangement. Check for errors and then press enter. The screen will look like this. And it does. Very close anyway. See it? As we mentioned earlier, there are 24 horizontal rows of character blocks on the, quote, grid of the screen. Therefore, you can only draw a vertical line, column that is 24 characters long. What will happen then if you enter a repeat value greater than 24? Let's try it. Clear the screen and then type in this statement. So let's clear the screen. Okay. Call VCHAR. VCHAR. And we want 1, 10, 86, and 50. 1, 10, 86, and 50. So row 1, column 10, character 86, which is a V, and 50 repetitions of it, 50 instances of it. And you'll see that it spills onto the next column and goes until we've exhausted all 50 characters, because each row has a maximum of 24, and then the screen scrolled up, so we lost a little bit. When you press enter, the screen should show this, and it does. Notice that it printed right over our statement that was already on the screen. Just print over what's already there. Your statement is partially replaced by the lines. After column 10 is filled in, the printing continues at the top of the next column, and so on. Note, graphics in the immediate mode only are affected by the scrolling of the screen. That's why you don't actually see all 50 of the V's above. Some have already scrolled off the top of the screen. We also mentioned earlier that there are 32 vertical columns. Therefore, it would seem that we could draw a horizontal line 32 characters long. However, some display screens may, quote, clip off the first two and last two columns, columns 1 and 2, 31 and 32. The only way to know what your screen shows is to experiment. So let's clear the screen and try drawing some horizontal lines. Type in this statement. So let's clear the screen. Now let's type in a statement. Call HCHAR, which prints a horizontal line, 17, comma 1. So row 17, column 1, character 72, which is an H, and 50. 72 and 50. Did I get that right? Let's double check. 72 and 50, yes. So we're going to hit enter. And we get a row of H's across the screen that spills onto the next line. And it looks very much like what you see here. About the same. After the printing filled one line, horizontal this time, and then started over on the next line. Count the H's. If you see only 28 in the full line, columns 1 and 2, 31 and 32 do not show in your screen, and you should use only columns 3 through 30 to avoid losing part of your graphic design. Of course, in this case, we're using an emulator, so we don't have to worry about that. But on old monitors, sometimes the screen could be clipped off a little bit. So far, we've entered actual numeric values in our statements. However, you can use the let statement to assign numeric values to variables and then use the variables in the call VCHAR and call HCHAR statements. Try this. Okay, we have a series of let statements here. Let A equals 5 and B equals 12. A equals 5. Let B equal 12. Oops. B equal 12. A little typo there. Okay, let C equal 67. Okay, call clear. Okay, now let's type call VCHAR A, B, and C. A, comma, B, comma, C. And we get the letter C printed. Where did the C appear on the screen? Well, it looks like row 5, column 12. Row 5, column 12. 5, 5 down, 12 over. For a big finale, let's fill the screen with asterisks, numeric code 42. Type these lines, pressing enter at the end of each line. So clear the screen. We're going to fill the screen with asterisks. How fun is that? Call HCHAR. We're going to do it in terms of horizontal drawing on the screen. 1, comma 1. So we're going to start in row 1, column 1, the very top left of the screen. 42, that is the numeric code for an asterisk, and I even remember that from when I was a kid. I did this so many times. And 768. So 768 repetitions. Make sure we got that right. 1, 1, 42, and 768. 24 rows by 32 columns equals 768 positions. All right, we're going to get asterisks on the whole screen. There we go. Boom. And then, of course, they're going to scroll up and give us a new prompt and cursor. Cute, huh? Lots of asterisks. Continue to experiment on your own, trying different characters. See Appendix B and positions. For example, can you fill the screen with your first name initial? All right, let's do that. Can we fill the screen with my first name initial? Appendix B. Let's see, where are we here? There we go. Appendix B. Let's just read Appendix B. All characters that print on the screen, letters, numbers, and symbols, are identified by numeric character codes. The standard characters are represented by character codes 32 through 127. These 96 codes are grouped into 12 character sets for color graphics purposes. Okay, so here's the character sets. We're not going to worry about this too much until we get to later chapters. But let's find, what is it, my first initial, which is a Z, of course, for Zachary. And let's find a Z. There it is, so number 90. So what we want to do, we want to call actually we'll do HCHAR, 1, 1, and we said it was 90, and so we're not going to dwell on the appendix here. But while we're here, let's read it. There are 32 additional character codes, 128 through 159, available for use in defining special characters for graphics programs. See Chapter 5 for a discussion of character definition. Again, these codes are grouped into 4 sets for color graphics. Okay, let's go back up to Chapter 1. Okay, so 768 was how many we needed. 768. And we should get the letter Z covering the screen momentarily. There we go. It's a lot of Z's. Take a nap. Summary of Chapter 1. This concludes our quote tour in the immediate mode, and you've been introduced to these basic statements. Print, call clear, let, call sound, call VCHAR, and call HCHAR. This chapter has given you a glimpse of TI Basic and your computer's capabilities. Now you're ready to get into the real fun, learning to program your computer. And that concludes Chapter 1. So next time we'll dive into Chapter 2, which is simple programming, but you'll have to wait until I can find a little time to record the next video. In the meantime, let's end on a high note. Let's type by, because it said we can type by and return to the start screen of the computer. And there we are. Well, everyone, thanks for tuning in. That was Chapter 1 of Beginner's Basic, the manual that came with the Texas Instruments TI-99 4A home computer. Be sure to follow me on Twitch. My handle is Cozy Azeroth, and you can find me on YouTube under Zachary Fruhling or Cozy Azeroth. Have a great day, everyone. Thanks for tuning in. Really appreciate it.